Okay, good morning, noon or after or evening. How are you doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. Today we're going to start talking about relations and functions and graphs of functions. We're going to be putting a lot of things together here today, in this chapter. And you're going to learn all about graphs and graphing, and it's actually quite fun when you learn the nuances and the little tricks that are there for us to be able to graph something very quickly and easily. I'm going to go rather quickly today because a lot of this is stuff that we have already seen at one point. Anything new, of course, I'll be sure to take my time with, but we got a lot to do, so I'm going to fly. First of all, we're going to talk about interval notation. Okay, interval notation, I don't know if you guys remember, but we did do this. Do you guys remember doing interval? Okay, so that's why we're just going to go real quick. It's a fancy way of writing inequality solutions. Here's how it works. When you're dealing with less than or equal, less than or greater than, you're going to use parentheses only. When you're dealing with less than or equal to or greater than or equal to, you're going to have a bracket. Whenever you're dealing with plus or minus infinity, please remember to use parentheses. Because brackets mean that they end. There's a termination. There's an answer. Infinity is forever. It will never end. When you're using interval notation, please remember that the format is always either the parentheses or the bracket, smaller value, comma, larger value, parentheses, or bracket, depending on what you have. So we're just going to go through these right quick. For example, write each solution using interval notation. So I've got x is less than 5. For anyone that cannot visualize this, please do yourself a favor, make a little mini graph. Here's 0, here's 5, it's less than. So what is the smallest value if I keep going to the left forever? That's exactly right, thank you. So negative infinity, comma 5. Okay, I use a parentheses because it's less than, not less than or equal to. Number 2, x is greater than or equal to negative 2. Again, real quick, 0, negative 2, greater than or equal to. It's going to the right. So what's my smallest value here? Negative 2 with a bracket, and it's going to positive infinity. X is greater than 3. Again, real quick, if you can't visualize it, open circle to the right. What's the smallest value here? 3, comma, positive infinity. That's my largest value. That's where it's going to. I have a parentheses because it's greater than, not greater than or equal to. Yes, sir? Oh, yes, that on the number, yeah. You could have used a parentheses here or a bracket, absolutely. Yes, sir.
So we have to know how to type on the graph and like for the quiz. We're gonna have to do it both ways.
Do you have to graph it for the quiz? No, sir. I mean, you should know the graph. The graph should be the easiest part of this, but I'm not going to require you to graph it, no. But you may have to later in the SAT. Now, which is the solution in inequality notation? How would I do this? 5 to infinity. What is that really saying? X is greater than 5. Excellent. Now, what about this? Bracket negative 3, 5 parentheses.
Negative 3 is less than or equal to.
No? Okay. Remember, guys, on the number line, this is what you should be visualizing. That's why number lines are great. It's everything in between, right? So doesn't that mean that X is greater than or equal to negative 3, but less than 5? It's everything in between negative 3 and 5. Why did I put a less than or equal to? Because I have a bracket for negative 3. Last but not least, negative infinity, comma 6. What's happening here? X is less than 6. Very good. Not less than or equal to, but just less than. Excellent. That make sense, boys? All right. Now, again, Mickey Mouse time. I just got to go through it. Please remember, the y-axis. This is your output. This is where you're going to find your output. The dependent variable is y, and the range is y. Your x, that's your input, your independent variable, or your domain. The point where the x and y-axis meet is that red point right there. It's called the origin, and that is my 0, 0. Okay? That's when x is 0 and y is 0. How do you know which is x and which is y? Because we already learned what an ordered pair was. An ordered pair is a parenthetic expression of a point where you have the x value first and then the y. So this point here is 1, 2, 3, 4 on the x, up 1, 2, 3, 3 on the y, 4, comma 3 is the point, and that is my ordered pair. We've also spoken about domain and range. Please remember that domain are all possible inputs, or all possible x values, or all possible independent values. Those are all the same things for x. X is independent, it's the input. Okay? Range. So all the possible y values, or the output. Y is the answer. When I have y equals 2x plus 3 and I put 0 in for x, I'm going to get y equals 3. The x is independent. That could be whatever it wants. I plug that in anytime I want. The y depends on x. You go to the movie theater and it's y equals 12x. If you buy one ticket, y is 12. If you buy 10 tickets, y is 120. Y depends on x. Make sense here, guys? So that's domain and range. Next. Okay. You don't have to memorize what I gave you here yet. We're going to have a whole section on this. But I like to make sure that you understand what I'm talking about. Today we're going to be graphing functions by using the table method. It is the worst method in the world. It is inefficient. It can cause a lot of numerical errors, but at the same time, it's the easiest way to do it. So we got to learn. And I just want you to understand the following. You can always make a table of values for any equation or function. I don't care what. Always. By choosing x values and finding the corresponding y value. Once complete, you can graph each point and then graph using what you know about the shape of the given function. So for example, if you know that you're dealing with a quadratic when x is squared, and we're going to deal with all of these specifically, don't worry, I promise. But if you're going to deal with when x is squared, you better know that it's going to be a U-shaped graph. So if you have points that plot like this, that you don't go like this. That's not it. You better know that it is a U-shaped graph. Oh, okay, that's the U-shape. Bam. Okay, so I'm going to go through a couple real quick. An identity function is when x is by itself. It has an exponent of 1. That's a linear equation. It's going to be a straight line. The quadratics, or the square root functions, that's when x is squared. It's going to be a U-shape. The cubic function, okay, the cube function, when x is cubed, you have this kind of like it's like a sideways S. It's like an S that went pointing down, if you can see. Okay? That's the shape for a cubic. You have what's called a reciprocal function, or a rational. Remember we talked about rationals when there's a variable in the denominator. It's going to be the function, the shape of a rational. You have a square root function. When x is inside of a square root, notice you only have one side of it. You only have the positive side here. That's going to be the square root function. And the cube root, similar to the cube, but it's reversed. Instead of it being an S that's like that, it's actually kind of a backward S that goes like that. Okay? All I want you to know from this is that there's these functions out there, and they have a set format. You're never going to have an x squared that comes out looking like this. Never, ever, ever. If you do, you know you messed up. Okay? Now, let's get to the point here. I'm not going to bore you by plotting points with linear equations. I pray that you remember how to do this. How do we graph a linear equation? What do we do first? Y-intercept 1, 2, 3, 4. Down 1, 2 over 1. Down 1, 2 over 1. Backwards up 1, 2 over 1. Bam. If you wanted to make a table, or at some point they say you have to make a table, remember the moral 5. Okay? Just remember the moral 5. So when it's negative 2, 4, 8, 6, 4, 2, and 0. I will not make you do a table for linear functions. That is ridiculous. Okay? You with me so far? All right. Now, how about this guy? All right. This is an absolute value, guys. Okay, this is an absolute value function. And there is a trick here. There is a trick that you can use. All right? And I'm going to go ahead and teach it to you. A lot of people would disagree with me, and they say, no, teach them how to make the table. The problem with the table with the absolute value, you could have all these points, and you're like, okay, man, I'm done. But guess what? If you connect those, that's just a straight line. An absolute value has a V. So what ends up happening a lot of times, even to me, who knows what he's doing, sometimes you're picking so many points, but you're only going on one side of it. So you keep choosing and keep choosing and keep choosing. You're like, oh my God, when is this ever going to turn to a V? Well, you got to go this way. So maybe you got to go down a little bit, and then it starts coming up. So you can literally sometimes pick 7, 8, 10, 12 points before you realize, oh, okay, I got to go to the other side. So that's a mission. So I'm going to show you a nice, easy way for absolute values. See this number in here? Okay? And then you have this number out here, right? I'm gonna give you the brief version now. I will explain all of this in a couple sections. But this formula, okay, this really inside of here is called an x minus h plus your k. The value in here is the opposite of what is shown because there's a minus here. This k here is legit. H stands for a horizontal shift, okay? And the k is going to shift the graph up or down. So this is what you're going to do. You're going to find the hk value. Remember that the h is always opposite of what's given. So in this particular case, my h is negative 4. My k is 3. It stays the way it's written. Graph that point. Negative 1, 2, 3, 4 up 1, 2, 3. Now, see this guy here? That's like my slope. But if you remember an absolute value function, guys, remember we graph these, they have a V-shaped graph. So I'm going to follow the slope to the right and to the left. So it's going to be down 1, 2 over 1, down 2 over 1 to the right. Now go to the left, down 1, 2 to the left, down 1, 2 to the left. So even though you should be making tables for this, you don't have to. Find your HK. Remember the H is always opposite of what's given. Graph your HK, follow the slope to the right and to the left. You feel me? Yes, sir. For the absolute value, it will always work. Yes, sir. Okay? There's one little complication that I could do to it, but we'll get to that. But for now, yes, that will always work. Does that make sense, boys? Yes, sir. Yes, sir. What did I do with the slope? Well, I graphed the HK. 1, 2, 3, 4, 1, 2, 3. Negative 4, 3. This is my slope, negative 2. I taught you guys that in slopes, you always run to the right. But since this is an absolute value, you run to the right and the left. So down 1, 2 over 1. Down 1, 2 over 1. Go back to the vertex. Down 1, 2, 1 to the left. Down 1, 2, 1 to the left. And now you have your perfect V-shaped graph. Sir?
What if there wasn't a K? Are you going to do
If there's no K, then it's 0. Right? If there's no H, then it's 0. Look, don't make a mountain out of a molehill. Look, let's go 2 absolute value of X minus 1. What's being added to the x here? So my hk is 0, negative 1. So I go down here, I'll do this in green. 0, negative 1 is right here. What's my slope? 2 over 1, right? So I'm going to go up 1, 2 over 1 to the right, up 1, 2 over 1 to the right. Now go to the left. Up 1, 2 to the left, up 1, 2 to the left. Bing, bang, boom. You're done.
What if it's like x plus 4, but there's no minus 1?
Like I said, then the k is 0. For example, y equals negative 1/3 absolute value of x plus 2. What's my hk here? Negative 2, 0, because there's no k. So negative 2, 0 would be right here at negative 2. My slope, down 1 over 1, 2, 3 to the right. Down 1 over 1, 2, 3 to the right. Go backwards. Down 1 over 1, 2, 3 to the left. Down 1 over 1, 2, 3 to the left. And that is your graph. Does that make sense? Thank you very much. Excellent questions. Okay. Y equals x squared minus 1. If you remember looking at the pictures I gave you, that's going to be a U-shaped graph. Right? So here, make a table for now. I promise you, we'll get to a point where we don't have to make a table for this. You're going to go to negative 2, negative 1, 0, 1, and 2. When x is negative 2, that's 4 minus 1 is 3. When x is negative 1, 1 minus 1 is 0. 0, negative 1, 1, 0, and 2, 3. So negative 2, 1, 2, 3. Negative 1, 0. 0, negative 1. 1, 0. 2, 3. In case you don't know what the shape is, look at the little function table that I gave you. There's a U-shaped graph. Bing, bang, boom, you're done. If y equals f, or f of x equals x cubed plus 3. All right, again, moral 5. When x is negative 2, negative 2 cubed is negative 8. Negative 8 plus 2 is negative 6. When x is negative 1, negative 1 cubed is negative 1 plus 2 is 1. When x is 0, 0 cubed is 0 plus 2 is 2. When x is 1, 1 cubed is 1 plus 2 is 3. When x is 2, 2 cubed is 8 plus 2 is 10. So, negative 2, negative 6. 1, 2, 3, 4, 5, 6. Negative 1, 1. 0, 2. 1, 3. And 2, 10. Oh my God, what is that shape? Remember the shape that I showed you at the beginning of the lesson. This is going to be like that upside down S. And there you go. If you don't know the shape, you're out of luck here. Does that make sense, my brothers? You promise? Okay. Now, let's identify the intercepts from the graph of an equation. Remember that the intercepts, the x-intercept is the x value when y is 0. The y-intercept is the y value when x is 0. Regardless of the function, the following statements remain true. X-intercept is the x value when on the x-axis when y is 0. The y-intercept is the y value on the y-axis when x is 0. By looking at these graphs, you can immediately tell, immediately, what the intercepts are. So let's look first at the x-intercepts. In this case, the x-intercepts are the x values on the x-axis when y is 0. So boom, yeah, you're right, negative 2. So negative 2, 0 is an x-intercept. That's 1. And this guy would be, it's going by, it's not clear here what they're going by 1, so by 2s. So that would be 3, 0. I'm sorry that the numbers are not clear. I apologize. Y-intercept, y value on y-axis when x is 0. So we got, what is this, 2, 4, 6. That's 8. So 0, comma 8. And that's it for my y-intercepts. Does that make sense, gentlemen? Okay. Let's look at example 5. My x-intercepts. Well, we got this guy right here, negative 3, 0. We got this guy right here and this guy right here. So 1, 0 and 2, 0. Let's find the y-intercepts in blue. The y-intercept is only this guy right here. And they're going by 4s, it looks like. So that should be 6. 0, comma 6. The y value when x is 0. Does that make sense? How about over here? My x-intercepts. My x-intercepts are, there go my 2's, thank you. So that's negative 4, comma 0. Great job, guys. Negative 1, comma 0. Great job. And 1, 0. Very good. In blue, we'll do the y-intercepts. Yeah, this was kind of tough, but it's right there. Yeah, we could say about 0, negative 4. And that's it for my y-intercept. Yo. The y-intercept's right here in blue for example 5. 0, 8, Pablo. I'm sorry. This guy right here. My bad. Thank you, son. Sorry about that. All right, what about for this circle? Let's do the x-intercepts in green. The x-intercept is right here, 5 and negative 5. So 5, comma 0, negative 5, comma 0. Done. My y-intercepts, bless you. I'll do it in red. 5, negative 5. So 0, 5, and 0, negative 5. Also, this guy right here, 0, 0. That's also an x-intercept. Thank you. And a y-intercept. Very excellent. Very excellent. Does that make sense, guys? Okay. Last example. Let's interpret this graph. Using the given graph, what is the profit? What is the profit, not is, if, sorry, what is the profit if 150 gallons of gasoline are sold? Well, let's look. Go to 150 gallons of gasoline, which is right here. Go straight up till you hit your graph. Oh, wait a second. Now go to the left. Boom, 200. Right? When x is 150. Oh, that's sloppy. When x is 150, y is 200. So that's how much money they're going to make in profit, in millions. How many gallons of gasoline are sold when the profit is highest? Okay, very good. 375. That's my x, that's my y. Y is profit, gallons is x. What is the highest profit? That's very good. 565. Very good. Very good. Identify and interpret the intercepts. Okay, there's 3 intercepts here. There's this y-intercept, which is 0, negative 200. What does that mean? That if I produce 0 gallons, I lose $200 million. You hear me? How about, I'll do this one in red so you can see what I'm talking about. How about this intercept? That's my x-intercept. 100, comma 0. What does that mean? Thank you very much. Great vocabulary. If you produce 100 gallons, you break even. You don't lose and you don't gain. And last but not least, 750, comma 0. What does that tell you? If you make 750 gallons, you also break even. So your ideal production is 565, so you can make 375. Yes, sir.
Why would it make it more like
Because apparently the way that the quadratic function was written, okay, there's some variables that take away. I don't know off the top of my head what the quadratic function is here. I'd have to calculate it. But it's just like when you throw a baseball, okay? When you throw a baseball, I don't care how strong you are. I don't care how fast you throw that ball. I don't care if it's King Kong throwing it. It's going to go really high, and then there's a little thing called gravity that makes it go down. So what we just saw was something similar to that. For some reason, it grows to a certain point, and then according to the equation, it starts decreasing past that point. It's a great question, son. Thank you. I appreciate it. Does that make sense? Awesome. Thank you very much. Hope you learned a lot.